Hello, I am Dr. Shruti Shruba Bharali and I welcome you all to this lecture video on applications of Python, which is a part of the online course on open source software for academia. In this video lecture, we will take a deep dive into the wide-ranging applications of Python. This lecture aims to provide clear understanding of how Python is used across various industries and domains, making it one of the most sought after languages in today's technological landscape. We will begin by exploring the different fields where Python is actively applied. One of the most prominent domains is data science and data analytics, where Python is used to clean, process, and visualize large data sets for meaningful insights. The lecture will also cover the role of Python in artificial intelligence and machine learning, where it is used to build intelligent systems capable of learning from data and making decisions. Additionally, we will discuss how Python plays a crucial role in scientific and numerical computing, particularly in academic and research environments. The application of Python in automation and scripting will also be highlighted in this video, showcasing how repetitive tasks can be simplified using Python scripts, saving time and improving productivity. Furthermore, Python plays a significant role in web development, where powerful frameworks like Django enable the creation of dynamic, scalable, and feature-rich web applications. After covering these diverse application areas, the lecture will transition into an introduction to essential libraries that further enhance Python's capabilities. In this lecture video, you will be introduced to Pandas, which is a powerful library for handling structured data for easy data analysis and manipulation. The video will also cover NumPy, which provides support for high-performance numerical computations and multidimensional arrays. In addition, the lecture will cover SciPy, a library built on NumPy that is widely used for scientific and technical computing, offering modules for optimization, integration, and more. By the end of this lecture video, you will not only have a strong grasp on the various domains where Python is applied, but also an introductory understanding of key libraries that make Python a powerful tool in various applications.
Applications of Python. Python has a wide range of applications across various fields due to its simplicity, versatility, and robust libraries. It is used in web development, data science, machine learning, artificial intelligence, automation, software development, game development, and more. From building dynamic websites and analyzing complex datasets to automating repetitive tasks and powering intelligent systems, Python serves as a powerful tool for both beginners and professionals across industries such as finance, healthcare, education, and technology. Let us explore some of the key domains where Python is widely utilized. The first domain is artificial intelligence and machine learning. Python has become one of the most widely used programming languages to build AI and ML applications. Its simplicity, clear syntax, large repository of high performance libraries, and extensive community support have made it developers, researchers, and data scientists' top choice. Python allows the development of intelligent systems capable of learning from data, identifying patterns, and taking sound decisions without specific programming for each task. Artificial intelligence and machine learning involve a wide variety of applications, and Python leads the charge in many of these pioneering areas. Let's see more about some of the key areas in which Python is an integral part of AI and ML. The first area is computer vision. Python is extensively utilized in cases dealing with interpreting and comprehending visual data from the world. Operations such as image recognition, facial detection, object tracking, and image segmentation are handled through libraries including OpenCV, TensorFlow, and PyTorch. Another area is natural language processing. Natural language processing allows machines to read, comprehend, and respond to human language. Python libraries like NLTK, Sparsy, and Hugging Face transformers are extensively used for purposes such as text classification, sentiment analysis, language translation, and chatbox creation. Another area is speech recognition. Python makes it easy to create applications that are capable of interpreting and processing natural speech. Such applications include voice assistants, auto transcription software, and voice controlled systems. Some popular libraries in this space are speech recognition, deep speech, and PyDub. Another area is autonomous systems. Python has an important role in creating AI systems for robots, drones, and autonomous vehicles. These systems need processing in real time, decision making ability, and environmental consciousness, all of which can be controlled through platforms like TensorFlow, PyTorch, and Robot Operating System. Another area is predictive modeling. Predicting future outcomes from past data is one of the most fundamental uses of machine learning. Python is extensively utilized for the development of predictive models for a number of different purposes, including customer behavior prediction, analysis of the stock market, healthcare diagnostics, and risk analysis by using algorithms and tools available through libraries like scikit-learn and XGBoost. To facilitate these varied AI and ML use cases, Python provides a broad set of specialized libraries and frameworks, such as TensorFlow, PyTorch, and Scikit-learn. The next domain is in the area of data science and data analytics. Python has become a leading programming language of choice for data science due to its robust data manipulation features, simplicity, and rich library ecosystem. It provides a complete toolset for all phases of the data science process, ranging from data cleaning and reshaping to statistical modeling and interactive visualization. Python enables data scientists and analysts to discover actionable insights from big and messy data, facilitating data driven decision making in various industries. One of the biggest contributing factors for Python's popularity in data science is its capacity to deal with, analyze, and visualize data efficiently. Whether structured data in spreadsheets or unstructured data from web sources and logs, Python offers the necessary tools to transform raw information into useful knowledge. Let us see the major applications of Python in data science. The first one is data transformation and cleaning. Raw data usually has inconsistencies, missing values, and noise prior to analysis. Python libraries, pandas, and NumPy are commonly employed to clean, structure, and pre-process the data into a workable form. Operations such as null value handling, data type formatting, and dataset filtering are handled efficiently through these packages. Another application is exploratory data analysis or EDA. EDA is an essential step in discovering the patterns and structure of the data. Matplotlib and Seaborn are Python libraries that facilitate the generation of visualizations such as histograms, box plots, and correlation matrices that indicate trends, anomalies, and relationships between variables. The next application is in the field of data visualization. In order to effectively communicate findings, Python facilitates the development of interactive, rich visualizations and dashboards. Libraries such as Plotly, Dash, and Streamlit enable users to create beautiful and dynamic interfaces that can be shared among teams or integrated in web applications. Another application is in the field of statistical analysis. Data science sometimes means extracting conclusions from data using statistical processes. Python's SciPy and Stats Models libraries contains instruments for hypothesis testing, linear regression, time series analysis, and other functions, and more, enabling deeper insights into data behavior. Another application is big data integration. In situations where data is too big for conventional tools to process, Python can be integrated with big data technology. Libraries such as PySpark allow Python to integrate with Apache Spark, supporting distributed data processing and real-time processing of large datasets. Some of the popular Python libraries for data science are Pandas, NumPy, Matplotlib, Seaborn, SciPy, and Plotly. The next domain area of Python is scientific and numeral computing. Python has become very popular in scientific computing and research, driven mostly by its unambiguous syntax, simplicity, and widespread collection of scientific libraries. Its readability and expressiveness make it a perfect tool for scientists, researchers, and engineers who are not necessarily from computer science backgrounds but require a versatile vehicle for data analysis, simulation, and sophisticated mathematical modeling. Python is extensively used in research environments at both academic and industrial levels, where it acts as a generalized platform for executing detailed scientific analysis, numerical experimentation, and reproducible workflows. Its applications cut across numerous scientific fields, and hence it is a popular language for research and development across interdisciplinary fields. There are many applications of Python in scientific and numerical computing. One of them is simulations. Python is extensively utilized to simulate and model actual physical systems in subjects like physics, chemistry, and biology. For example, scientists simulate fluid dynamics, molecular interactions, and ecological systems in order to learn more about natural phenomena. Another application is mathematical computation. Solving complicated mathematical issues related to calculus, linear algebra, and symbolic maths can be done quite efficiently with Python libraries such as NumPy and SymPy. Another application is in the field of astronomy and astrophysics. Researchers in these domains frequently work with large quantities of observational data from satellites and telescopes. Python's Astropy library provides specialized software for processing astrophysical data, unit handling, and celestial coordinate math. Another application is in the field of bioinformatics. Python has an important role to play in computational biology and genetics. Libraries like BioPython allow researchers to carry out tasks such as DNA sequence alignment, protein structure prediction, and genome data analysis. Another application is engineering calculations. Python is utilized by engineers to solve engineering problems like structural mechanics, circuit simulations, signal processing, and control systems. SciPy provides strong modules for numerical integration, optimization, and differential equations, which are important in the field of engineering. Some of the popular Python libraries for scientific and numerical computing are NumPy, SciPy, SymPy, AstroPy, and BioPython. The next domain is automation and scripting. Python is perhaps one of the best scripting and automation languages because it is easy, readable, and has a powerful standard library. It enables users to automate repetitive jobs, system administration, and optimize workflow processes in a variety of applications. Python provides an open and versatile platform to design automation solutions. Automation reduces human error, saves time, and improves task consistency, which otherwise would be tedious and manual. Python support for automating tasks from multiple systems, handling files and data, accessing web services, and scheduling operations makes it a priceless resource for automating day-to-day tasks. Let us look at some of the important applications of Python in automation and scripting. The first one is file management. Python can be used to automate operations of a file system, including the renaming of multiple files at once, sorting files into folders by type or date, making backups, and removing obsolete files. Libraries such as OS and Shuttle offer powerful tools for accessing the operating system and working with files and directories. Another application is web scraping. It can take too much time to get data manually from websites. Python makes it easier using libraries like Beautiful Soup and Scrappy to automatically extract web page information, making it possible for users to construct datasets for research, business intelligence, or competitive analysis. Another area is automated testing. Automated testing is very essential for code quality and reliability in software development. Python offers library like PyTest and unit tests for automatic test case writing and execution. This makes it easier for developers to identify bugs early and have high quality code. Another application is task scheduling. Python programs may be scheduled to run automatically on a set schedule using applications such as Korn on Unix like operating systems or Task Scheduler on Windows, in conjunction with Python libraries including Schedule. This is useful for automating routine tasks like data backups, report generation, or system checks. Another application is email and report automation. With Python, one can use it to create personalized reports directly from databases or spreadsheets and automatically send them via email. This is particularly useful in commercial environments for sending out daily reports, reminders, or performance reviews without the need for manual effort. Some of the popular Python libraries used in automation and scripting are OS, Shuttle, Schedule, and Beautiful Soup. Another key domain of Python is in the field of web development. Python has emerged as a leading language in web development due to its clean syntax, high speed development, and wealth of frameworks and tools. Python enables developers to construct powerful, scalable, and secure web applications with less code and high efficiency. Whether designing a basic personal blog or a highly complex enterprise level application, Python provides the power and flexibility to offer professional web solutions. Web frameworks built on Python make most of the complexities of web development easier by offering built in modules to deal with typical tasks like routing of URLs, form handling, authentication, and database management. This saves time and keeps code bases cleaner and easier to maintain. Let us look at some of the important applications of Python in web development. The first application is web applications. Python is used to create different types of web applications such as e-commerce sites, blogs, portfolio sites, educational websites, and social networking sites. Frameworks like Django and Flask provide quick development and straightforward deployment, which allows web services to be launched faster. Another application is RESTful APIs. In modern applications, particularly in mobile and front end oriented environments, APIs are essential. Python frameworks such as FastAPI, Flask, and Django REST framework make it possible to develop RESTful APIs that facilitate communication between backend services and front-end clients or third-party apps. Another application is backend services. Python drives the backend functionality of web applications, handling user authentication, session management, data validation, server side calculations, and database interactions. This is the central engine driving the working of a website or application. Another application is data driven websites. Python integrates naturally with databases like PostgreSQL, MySQL, and SQLite, and with data visualization libraries like Plotly and Bokeh. Developers can thus design dynamic websites to present and refresh real time data, dashboards, and analytics tools. Another application is microservices architecture. Python is also well suited to creating microservices, that is, small isolated pieces of a big application. Fast API and Flask frameworks facilitate the creation of lightweight modular services that can scale independently, leading to improved system performance and easier maintenance. Some of the popular Python libraries used in web development are Django, Flask, and Fast API. Python has a vast array of libraries, but in this video lecture, we will cover three of the most potent and widely used ones, which are Pandas, NumPy, and SciPy. Pandas is a general purpose library that is geared towards handling structured data. It makes it easy to perform data analysis, cleaning, and manipulation through easy to use data structures such as data frames and series. NumPy is the core package for numerical computation in Python. It offers high performance operations on large n-dimensional arrays and matrices, together with a range of mathematical functions to manipulate them. SciPy extends NumPy and adds more capabilities for scientific and technical computation. It comprises specialized modules for optimization, integration, interpolation, and statistical analysis. Let us now look at each of these libraries in detail. Pandas is a very popular and feature-rich data manipulation and analysis library for Python. Pandas has seen extensive application in data science, machine learning, finance, scientific research, and business analytics due to its ease of handling and analyzing structured data. Pandas has two main data structures. Series, which is a one-dimensional labeled array that can hold any data type, which is similar to a column in a spreadsheet or a single list with labels. And data frame, which is a two-dimensional tabular data structure with labeled axes, rows and column similar to an Excel spreadsheet or a SQL table. These structures are designed for fast, flexible, and expressive data manipulation. Pandas is equipped with an array of powerful features that render it a core tool for data manipulation and analysis in Python. It has the feature to read and write data seamlessly from any file type like CSV, Excel, JSON, and SQL databases, which makes it very versatile for practical data handling. It offers powerful tools for data cleaning and preparation, such as missing value handling, data type conversion, and column or index renaming to make datasets more readable and standardized. With Pandas, users are able to effectively select and filter particular rows and columns through intuitive indexing techniques, enabling users to do very precise data exploration. Another very useful feature is merging and joining datasets, which permits users to join data from various sources through database style joins. Pandas also performs well when reshaping and manipulating data, providing tools for pivoting tables, stacking and unstacking columns, and reshaping databases to fit analytical requirements. It also provides comprehensive support for time series data, including resampling, date change creation, and rolling window calculations, which make it especially valuable in scientific and financial uses. NumPy, which stands for Numerical Python, is a core open source library in Python applied for numerical computation. It offers extensive support for the creation and manipulation of arrays, numerical operations, and efficient computation on big datasets. NumPy is applicable in numerous areas such as data science, machine learning, scientific computing, image processing, and engineering because it is fast and flexible. NumPy provides a variety of powerful features that make it a must-have library for numerical computing in Python. At its core is the NDArray object, which provides support for creation and manipulation of n-dimensional arrays. One of the biggest advantages of NumPy is its ability to support vectorized operations, through which operations can be performed on entire arrays without requiring explicit loops, leading to speedier and more efficient code. Broadcasting is another important aspect where NumPy can easily perform arithmetic operations on arrays of varying shapes in a very flexible and easy to understand way. NumPy also supports an extensive library of mathematical functions such as linear algebra operations, statistics, Fourier transforms, and even complex number calculations, which makes it ideal for diverse scientific and engineering applications. It also supports random number generation, which allows generating random data sets to be used in simulations and probabilistic modeling. The library is optimized for both memory usage and high performance, and thus is perfectly suited to process large data sets. NumPy also plays very well along with other Python libraries such as Pandas, SciPy, Scikit-learn, and TensorFlow, providing the underlying framework for most of their operations. All in all, the performance, functionality, and ease of use offered by NumPy make it a pillar of scientific computing within Python. SciPy or Scientific Python is an open source Python library based on NumPy for scientific and technical computing. SciPy offers a variety of modules to compute complex scientific tasks like optimization, integration, interpolation, signal and image processing, linear algebra, and statistical analysis. It is extensively used in engineering, physics, bioinformatics, data science, and machine learning studies. The SciPy library provides an extensive collection of features aimed at facilitating scientific and technical computing in Python. It is based on NumPy, and SciPy enhances its capabilities by including a rich set of modules for sophisticated mathematical operations. Its strength lies in the optimization module, where users can minimize or maximize functions using diverse algorithms for linear or nonlinear problems. Furthermore, SciPy provides strong support for numerical integration, which allows definite integrals to be calculated accurately and ordinary differential equations solved using the integrate module. SciPy also has a highly capable linear algebra module which provides operations more capable than NumPy, such as metric decompositions and solving systems of equations. Those handling signals or images will find the signal processing and image processing modules useful for filtering, convolution, transformation, and feature extraction. The interpolation module comes in handy for approximating values in between data points, while sparse matrix support enables efficient storage and computation on large matrices with lots of zeros, which is perfect for very large problems. The statistical analysis functionality of SciPy is extensive, ranging from various statistical functions, tests, and probability distributions. The library also supports fast Fourier transforms to perform frequency domain analysis, and hence it finds its application in physics and engineering. All these functionalities seamlessly integrate with NumPy arrays and can be easily integrated with other scientific libraries such as Matplotlib and Pandas. And hence, SciPy is a central part of Python's scientific computing system. Let's take a moment to assess your understanding with a couple of quick multiple choice questions. This will help you review and reinforce what we have covered in this tutorial. Here is the first question. What is one of the primary benefits of using Python for automation and scripting? Take a moment to think about your answer. The correct answer is option C, reduces human error and saves time. Here is the next question. What is the function of the OS and subtle libraries in automation? Take a moment to think about your answer. The correct answer is option C, handling files and directories. Here is the next question. What does NumPy stand for? Take a moment to think about your answer. The correct answer is option B, numerical Python. Here is the next question. Which of the following fields uses Python for image recognition and object tracking? Take a moment to think about your answer. The correct answer is option B, computer vision. If you got all the answers right, good job. If not, don't worry. You can revisit the explanation in the video.
This video lecture provided an insightful overview of Python's wide range of applications across various domains such as data science, artificial intelligence, machine learning, scientific computing, automation, and web development. It highlights how Python's simplicity and flexibility make it suitable for many applications. The lecture also introduces essential libraries like Pandas, NumPy, and SciPy, which enhance Python's capabilities in handling, analyzing, and computing data. Thank you for watching this video.